Hello, welcome to this video where we're going to be finding common denominators of rational functions. There's an example question on the front slide here and we'll work our way up to that. So if you first just look at some numerical fractions, when you want to find a common denominator, you're looking for a multiple of both 7 and 3. Typically your teacher likes you to find the lowest common multiple, but any multiple will do. If you're ever desperate to find a multiple of both 7 and 3 and you can't think of one, just multiply the denominators together. 7 times 3 is 21, and that is a multiple of both 7 and 3 guaranteed, because they multiplied to make that number. So in order to change our denominators so that they are the common denominator, for the 7 I'd have to multiply it by 3. Whatever you do to the bottom of a fraction, you have to do to the top to keep the fraction representing the same amount. I get 3 over 21, and then the 3 I would have to multiply by 7, do the same to the top, and I would get 14 over 21. However, if you're in pre-cal, you're going to start looking at denominators that are not numeric necessarily. So if you have single term denominators, if you have an x in a denominator and a 5, again, just like we multiplied the 7 and the 3 together, to find a common multiple of those two things, just multiply them together. 5 times x is 5x. So your common denominator is 5x. So in order to change x into 5x, we need to times by 5. We need to do the same thing to the top of the fraction. You get 15 over 5x. And in the second fraction, we need an x with that 5, so we need to times by x. And whatever you do in the bottom, you have to do on the top. So I'm going to end up with 4x over 5x. And now I have my common denominator and I'm ready to add those fractions together. If you have multiple term denominators, the theory is the same. You just have to be careful with the top of the fraction. So here I've got a denominator of x plus 3 and a denominator of x minus 1. To get a common denominator, I'm just going to multiply those two things together. Now you might recognize this as a binomial multiplied by a binomial, but I'm not going to expand it out to get x squared plus 2x minus 3, because it'll make it harder for me over here. I'm just going to leave it in its factored form and come over here and see what I'm missing. In this first fraction, I've got an x plus 3. So in the denominator, to get to my common denominator, I need an x minus 1. And whatever I do to the bottom, I do the same to the top, just like the first example. The danger here, where you have to be careful, is that this 4 has to be distributed through the brackets. So that first fraction is going to end up being 4x minus 4 over the common denominator of x minus 1 times x plus 3. In my second fraction, I've got an x minus 1 in the denominator. Put brackets around it to show it's grouped. I need to multiply by x plus 3 to get to my common denominator. Whatever I do to the bottom, I do to the top. And again, don't forget to distribute that number. So I'm going to get plus, what's this plus? 2x plus 6 over our common denominator of x minus 1 times x plus 3. And again, now that you have a common denominator, you're ready to add those fractions together. Finally, we get on to the slide that has the example from the front page. We've got denominators that have multiple terms, two two-term denominators and one quadratic sitting down here. You could just multiply x minus 1 times x plus 5 times the quadratic to get a common denominator, but that might get a little bit messy. Too many x's floating around. Typically when you see a question like this and you see a quadratic sitting there, it's basically asking you to factor that quadratic. When I factor this quadratic, and there is a video on factoring that you can refer to if you need a bit of factoring help, just look at the link below this video. Right, so I've got x and x, I've got 5 and 1 as my factors of 5. It's got to be a plus 5 and a minus 1. And you'll notice that the two factors of the quadratic are the two other denominators that we see over here. This is your common denominator. ready to go. We just have to work on the two fractions on the left here in order to get the same common denominator. So in this first fraction, I've got an x minus 1, so I need to multiply the top and the bottom by x plus 5. That will give me x squared plus 5x over x plus 5 times x minus 1. And then plus, here I've got an x plus 5, I got to squish this in, so I want to multiply by x minus 1, and I do the same thing to the top. Now again, you've got to be careful on the numerator here. We've got a full distribution problem here, binomial times binomial, so I end up with x squared minus x plus 2x gives me plus x minus 2 for that last multiplication over my common denominator of x plus 5 times x minus 1. Please forgive my writing on this little pad. And this other fraction on the other side of the equation already had the common denominator of x plus 5 times x minus 1, so no change is needed. Once you have the common denominator, your teacher will walk you through the steps of actually solving this equation, but this video is just focused on getting those common denominators. Thanks for watching.